Hi all. Today let us see how to calculate the DC capacitance value for a given motor. So why we need to add the DC capacitance value? So DC capacitance value is added because to increase the starting current of a motor. So let us consider 100 kilowatt motor for this. So 100 kilowatt motor is having a 6 times starting current. Okay, so from the soft starter we have reduced it to 4 times, but our client needs 3 times starting current. Like we need to reduce it to 3 times, that is like -1. Again, we need to reduce it to 3 times. So how to reduce it to 3 times? So there is no option in soft starter like in order to reduce this. So we need to add DC capacitance value, the capacitance value for the short time duration, because until the motor get accelerated to its full load, that means in order to full load to its full speed, we need to add DC capacitance value. So for this I'll tell you how to calculate it. So we'll consider 100 kilowatt motor. First we need to calculate what is the full load current at normal condition. So for this, 100 kilowatt divided by, again voltage is 1100 into root 3 into voltage into 0.85, that is power factor. So that is 62 amps. Okay, so next this is 62 amps. So now we need to calculate kVA at starting, that is root 3 into VL into I starting. So for this we need to consider I starting as 4 times, because the soft starter has already reduced it to 4 times, so there is no point of taking 6 times here. So root 3 into, again 1100 into, again this is 62 into 4. To 1100 into, again 62 into 4. Sorry, 62. So this is 472.5K. Now kilowatt at starting is kVA into power factor, 2.5 into what is power factor? Let's say it is 0.2. In the starting, keep in mind, in the starting the power factor is like too low, so into 0.2, that is 94.5, 5K is the wattage of the motor. So we need to calculate kVAR with this. So this is vector calculations. So kVAR is equal to kVA square minus kilowatt square, that is 0.5 square minus 0.5 square, square root of okay, 72.5 square minus 94.5 square. Okay, 462.9 is the kVAR value. kVAR value. So we need to reduce from 4 to 3 times. So for this we need to calculate kVA again at 3 times, root 3 into VL into IL into 3 times, that is equal to what is VL, 1100 to 62 into 3, that is again 3 into 1100 into 62, 3, 354.37 K VA values. So again kilowatt is constant, so you don't have to change the kilowatt. plus 94.5k. Find the kVAR value now. So kilowatt is constant, you don't have to find the kVA kilowatt value. It is this much. Okay. Let's say in kilowatt is this much. So next kVAR is equal to again square root of kVA square minus kilowatt square. Why I'm keeping this as constant is so we have to take some reference. So for us kilowatt is the reference. So that is equal to 354.37 square minus 94.5 square. And that is equal to 354.37 square minus 94.5 square. Square root of answer 341.5. Again, so this is the kVAR value. So in order to reduce it to three times the starting current, what I will do is, so kVAR at 4 times minus kVAR at 3 times. So this will give me that extra one time what we need to put. So what is the power factor capacitance that we need to add. So that is 462.9 minus 341.5 minus 462.9. That is not negative. I just wanted to make it a little faster. So round off, it is 122 kVAR. The capacitor needed is 122 kVAR value. kVAR is reactive power needed is 122. So in the capacitor banks we can so 122 is an odd number, so we can take a little higher than 122. So that's it for today. Again, so for how much current, like what is the value of current that can be drawn from the transformer. So there is a limitation to add the capacitors. So what is that limitation? So how to add this capacitor? So like you cannot simply add you cannot increase the value of capacitor to higher value, because we have inrush current in the capacitor, and again capacitor current we have. So what are the limitations and how to overcome and how to add it? So that I will be taking in the next class. Okay, thank you.